Hello, my wonderful computer science students. Welcome to another lesson in AP CSA. I'm Goldie and I'm here to take you through the very last video in Unit 1. So Unit 1 was all about using objects and methods. It was a great introduction into the Java programming language. And now we get to finish with our last lesson, which is Lesson 8. It's going to be all about the math class. And it's going to be also an introduction into using class methods. Okay. Now the math class here is part of the Lang package that gets imported automatically. So that was the case with our strings in the last lesson. We could use those string methods without any second thought because they were imported with the Lang package. And it's going to be the same thing with all of the methods in the math class. Now the math class is different from the string class because the math class contains static methods, which means that we actually don't use an object reference to call on them. We use the class name itself before the dot operator in our method. Okay? So what you're going to see here when we call these math methods, we use math, capital M, math dot, and then the method name that we want to call. There's so many math methods. The list is quite extensive, actually. There's 5 that you are responsible for on the AP exam, and we're going to go over now. So these 5 are the ones you got to know, but if you are interested, look up that API documentation because there are so many that you can use in your program. Okay. So here are the 5 that are detailed in your Java Quick Reference, that kind of formula sheet that you can use on the AP exam. These are listed there. So you don't necessarily have to have them memorized in that sense, but you should know what they are and be able to easily trace and use them in your program. The first one says int abs int x, okay? ABS, okay? That's going to stand for absolute value, okay? You pass it an int as a parameter and it's going to return an int, okay? So that first int signals the return value. So you're going to return an int. So what it does, it returns the absolute value of that integer value. So if you make the call math.abs and in parentheses you put a -7, it's going to return back a 7. Okay. All right. Second math method, even better. It's the same method. It's an overloaded method. Okay. The same method name, but they take 2 separate parameters. The first one is an int. The second one here takes a double. And it's going to return a double, okay? Guess what it does? It returns the absolute value of a double value, okay, of a double variable. So if you pass it a double, like let's say 5.67, what's the absolute value of 5.67? It's 5.67, okay? The absolute value of a positive is still the number itself. The absolute value of a negative, you should know, okay? So those are the first 2. We're doing good so far. The next one is POW. Okay, so we've talked about how Java does not have any built-in operator for an exponent, like the caret symbol on your calculator. There's none of that in Java programming. Instead, we have POW. Okay, so POW stands for power. You're going to pass it 2 values, the base, and then the exponent component, and it's going to return a double value. Now, I say it accepts 2 doubles, but it can also accept 2 integers, okay? There's not an overloaded method for this one. It accepts if you pass it 2 integers into here, it's going to upgrade those integers into doubles, perform the operation, and return a double result, okay? So the first parameter raised to the power of the second. So if you have 4.5 comma 2, even if you mix it and pass it a double and an int, it's going to give you 20.25, okay? Why is that? Okay, well, because it's 4.5 raised to the second power, which is 20.25, okay? The first value raised to the second value. So that's POW. The next one is sqrt. That stands for square root. Again, you pass it a value and it returns the result, the square root of whatever value you passed it. You can pass it a double, you can pass it an integer. It will always return a double value no matter what you pass it. Okay, so that's important to note for this POW too. Okay, like if you pass it a 3 and a 2, it takes 3 to the second power, which is 9, but it returns it as a double. It returns it as 9.0. Okay, that's different from the ABS because ABS, it depended on what you passed it. If you passed it an int, it returned an int. If you passed it a double, it returned a double. Okay. Maybe that doesn't make a difference in your program, but maybe it does. So remember that. Okay, so square root returns the positive square root of a double value. Okay, so math.sqrt 25 will return a 5.0. Okay, square root of anything. All right, the last one that you got to know is random. Okay, so random, it has no parameters. It is just random, and then it returns a double. What does it return? It returns a double value greater than or equal to 0 and less than 1. Okay, it returns double. And when you call it math.random, it'll be a long decimal. Okay, we're talking a random number, a random decimal between 0 and up to, but not including 1. Okay, so just totally random. Every time you call math.random, it will return a random decimal like that. Okay, and those are the 5 ones that you got to know for the AP exam. Like I said, so many more. Some might be even useful in the programs you write in this course, and you're welcome to use them if you want to look them up and use them properly. Okay, but let's trace through a few problems using these methods. Okay, so one of the ways we test you on this is just to see if you can trace through and see what's executed. Okay, so if I have int x equals 9, y equals 2, double answer 1 equals math.abs y minus x. Okay, I got to evaluate that. Y is 2 and x is 9, and abs is the absolute value of that difference. Okay, so because that method has a expression in between those parentheses, it's going to evaluate that expression first. So 2 minus 9 is negative 7. And then it takes the absolute value of negative 7, which is 7. It'll store 7 in answer 1 as a double, okay? And the answer is 7.0. Okay. Now, why did it store it as a double? Because this is an integer, right? I took the absolute value of an integer. Well, you took the absolute value of an integer, but then you stored it in a double variable, okay? So that upgrades it. It's now a double. Okay. You could have had int answer 1, and then when you printed off answer 1, it would print an actual just plain 7, but you had a double there, so it returned a double. Okay. Here's another one. Answer 2, math.pow, 9, 2. Okay. What is 9, 2? It means 9 raised to the second power. 9 raised to the second power is 81. This method always returns a double. And thankfully, you had a double to capture that, okay? And then when you print off answer 2, you're going to print off 81. It's beautiful, isn't it? Beautiful. Square root, okay? Notice how you have square root times y, okay? Which means this multiplication is going to happen between the square root of x and y, okay? This has to get evaluated first before you can multiply it by y. All right, before you can multiply by y. So the square root of 9, because x is 9, times 2, because y is 2. The square root of 9, the square root of 9 is 3. Okay, so that's going to be a 3.0 times 2, that's a 6.0, stored as a double, and you get answer 3, which is 6.0. Now let's talk about random numbers. Okay, this is the good stuff right here. Okay, you can trace through with those other ones. You can use them in math expressions that you need to write your program. Random numbers, because there's also points in programs where we need to have our computer produce a random number. Okay, so math.random produces a random decimal between 0 and 1. Very useful. We'll use them often in a lot of the programs we write. But most of the time when we write those programs, we're actually interested in a random integer, okay, not a random decimal. So what do I do in that case? Well, we use smart math. Okay, we use some smart math expressions in Java, and we can transform this random decimal into a random integer. So I'm going to kind of build up to it and show you what it looks like. So if I have this code segment, what are the possible numbers that are printed from it? So if I have math.random times 10, okay, what are the possible numbers that could come up? Okay, well, the smallest decimal is 0, right? 0 times 10 is still just 0, okay? So the smallest possible number is still 0. the largest possible number. Well, the largest decimal up to but not including 1 is 0.999999, right? Repeating. Okay. 0.99999 repeating times 10. What is that value? Well, that's still 9.9999999, right? So this code segment will give you any decimal value between 0 and up to, but not including 10, right? Because the highest is 9.9999999. Okay, so just with this code segment, we've already introduced some integer components. We still have the decimal, but we've already introduced some integer components. If we change this to 100, okay, same idea. The smallest number is 0 times 100 is still 0. The largest number, 0.99999 times 100 is 99.99999. Okay, so this code segment produces any decimal value between 0 and up to 100, okay, but not including 100. Okay, so we're getting closer to those integer components. How do I actually just get an integer? I'm going to throw in a cast. Okay, I'm going to cast it up here. I'm going to wrap it up nice and tight so that I can chop off all of the decimals and just keep my integer component. What happens in those same values from 0 times 10 is still 0. If I cast it to an int, that just becomes a 0. Okay. Same thing, 0.99999 times 10, that was 9.99999. And if I cast that, that becomes just a 9. Okay. So with this code segment, I have just created any integer value between 0 and 9. Whatever I create here, okay, even if it's like 4.3745, blah, 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 I just casted it. So it's just going to chop off this decimal and give me a 4, okay? That's how I'm going to make any integer value. Same thing here. This goes from 0 to 99 when I cast it. So this is going to give me any integer value between 0 and 99. Now from there, what if I don't want to start from 0? So if I write a program and I want a random number between 0 and 9, great. What if I don't want it between 0 and 9? What if I want it between 1 and 10? Or 5 and 300, right? What happens if you don't want it to start at 0? And what happens when we want it to go up to a certain value, okay? That's where we add on, okay? So here, notice I have the same code segment I've been working with. Now I have a +1, okay? So what happens, we know that this gives us any integer from 0 to 9. If I add 1 to the lower and upper boundary, now the lower boundary is 1 and the upper boundary is 10. So this gives me any integer value between 1 and 10. Same idea here, okay? I know that this code segment right here gives me a range from 0 to 99. If I add on 8, the lowest random number is 8 and the highest random number is 107. Okay, so any integer value between 8 and 107 is what that code segment gives me. Okay. So now I've built up almost this sort of formula or template to get any integer value that I need. Okay. So using that kind of logic, here's our generic code segment. Okay, again, kind of like our template. If I want an integer, I want an integer, a random number integer. This is what I'm going to use. This is like the template. I take Math.random times some sort of range, cast it, and then add on a starting value. Okay, range represents the number of values between the two endpoints that I want, but you got to think about if you want the endpoints included too. Okay, so that's a little tricky part I'm going to explain in the next section here. And then starting value represents the first integer number you want the random number to potentially be. Okay. So if I am given a task that says write a code segment to generate a random number between 15 and 35 inclusively. So remember, inclusively means including the two endpoints. So I do want my random number to maybe be 15, maybe be 35, or any integer between. Exclusively means excluding the endpoints. Okay. My range is 21, okay, from 15 up to and including 35. Now, this is probably the number one mistake I see with this, is students take the upper endpoint and subtract the lower. And they say, okay, 35 minus 15, that's 20. 20 is my range, okay? But that value, when you do subtraction, it doesn't include the endpoints, okay? It includes actually technically one endpoint, 15. But it doesn't include the upper endpoint, which you want, okay? So if you do it this way, which is fine, just know you're going to have to add on 1 if you want inclusivity, okay? You subtract 1 if you want exclusivity, okay? Exclusivity, if you don't want to include the endpoints, okay? So range is 21 here, okay? 21 values between 15 and up to and including 35. My starting value is 15, okay? So those are the two numbers I need to then write my code segment. My code segment then becomes Math.random times 21, cast it to an integer, and then add 15, my starting value, okay? And that's going to be the code segment that gives me that random number between 15 and 35. Okay. Our last task, this is the last thing we're going to do in this video. We are going to write the code that simulates rolling 2 dice and calculating the sum. Okay. So again, we're kind of expanding on this idea that we need a random number in our program. But what we have to be careful of when we're writing code that uses random numbers, we want to make sure that we are preserving probabilities, okay? Okay, and I don't say that just because I'm also an AP Stat teacher, okay? We got to preserve probabilities in our program. If I want to roll 2 dice and calculate the sum, okay? The sum could be anywhere from 2 to 12, okay? Think of rolling 2 dice. I could have snake eyes, I could have 2 1s, or I could have 2 6s. So the sum of them goes from 2 to 12. Okay, that doesn't mean that your range is all of a sudden 11 and your starting value is 2, and then you can use that template we just created, okay? Because when you use Math.random, each number is equally likely. And when we're talking about the sums are not equally likely, okay? So when you are modeling something in the real world, like rolling 2 dice, you have to make sure you preserve those probabilities. Otherwise, your computer simulation is not going to work properly, okay? The probability of getting a sum of 2 is much different than the probability of getting a sum of 7, let's say, okay? Because getting 2 is 2 out of, you think I would know this off the top of my head, 36, or excuse me, 1. What kind of teacher am I? 1 out of 36 is the probability of getting a sum of 2. Versus a 7, to get a sum of 7, there's 6 possibilities, okay? Those have different probabilities, okay? And because they have different probabilities, you can't just say your starting value is 2 and your range is 11. So what do we do instead? Well, we just make the code match what's actually happening in the real world, okay? In the real world, we're rolling 2 dice randomly. Now, with each roll of the dice, the probability of any number is equally likely. So let me just simulate that in my program. So first dice, I have 6 possibilities on my dice, and the starting value is 1. Okay. Same thing with my second dice. 6 possibilities, my starting value is 1. Now I've simulated rolling 2 dice, and now to get the sum, I just take the first die and the second die, what they each read, those 2 numbers I randomly generated, and I added them together. And now I get the sum. Okay? All right. So that is not a warning. A warning sounds harsh, but that is just an awareness of if you're using random numbers to simulate something that's occurring in the real world, make sure that you are doing it in a way that keeps the probabilities the same. Okay. And that actually brings us to the end of this lesson, and it brings us to the end of this unit in general. Okay. We are done with unit 1 now, using objects and methods. The next unit is all about selection and iteration. So we get to expand on a lot of these ideas that we've created a foundation for, and add a few new things as well. So if you've liked this video, please hit the like button and subscribe to my YouTube channel for more of that CSA content. But I've appreciated you sticking with me so far, and I will see you starting in Unit 2.